In this video, we shall learn about the influence of westerly and the easterly jet streams on the monsoon of India. To begin with, what are jet streams? Well, jet streams are a narrow belt of high altitude westerly winds in the troposphere. They are located close to tropopause and their speed varies from 110 kilometers per hour in summer to about 184 kilometers per hour in winter. In terms of latitude, these jet streams are located approximately over 27 to 30 degree north latitude. Therefore, they are known as subtropical westerly jet streams because they are very close to the tropical areas. Their paths typically have a meandering shape, that is, they move in a zigzag manner. Jet streams may start, stop, split into two or more parts, combine into one stream, or flow in various directions, including the opposite direction of most of the jet. Over India, these jet streams blow south of Himalayas all through the year except in summer. In summer, the subtropical westerly jet streams move north of Himalayas. It is because of the apparent movement of the sun. In summer, the apparent movement of the sun is in the north. Now, even the Tibetan plateau gets heated up, low pressure is developed, and it pulls the westerly jet streams northward. Now, jet streams also determine the arrival and departure of monsoon. Let us understand how. We have seen that the Tibetan plateau gets intensively heated and so a low pressure area is created. Whenever a low pressure area is created, the wind from the nearby areas will be rushing towards those regions. These winds not only just come towards these low pressure areas, they also bend. Now, since these winds are in the northern hemisphere, they will bend towards the right. It is because of the Coriolis effect. We can call this as a cyclone where a low pressure is created and the winds are attracted towards it. So, in this region, at the lower altitudes, the winds move in an anti-clockwise direction. The warm air in this region starts rising up, and as the wind is rising, we all know it starts cooling. It finally reaches very close to tropopause. Since at this point the air is cool and the temperature is low, so the pressure is high. Now, if the pressure is high, the wind in this region tend to move away from this region. As the wind is moving away, they will bend towards right, because the winds bend towards right in the northern hemisphere, and they will not only bend, they will also rotate in a clockwise direction. A large-scale circulation of winds around a central region of high atmospheric pressure is known as anticyclone. The cyclones move in an anti-clockwise direction and anticyclones move in a clockwise direction in the northern hemisphere. This anticyclone in the upper troposphere weakens the western subtropical jet stream, and it also produces tropical easterly jet streams on the south side of the anticyclone. Now, these western subtropical jet stream divides into two. One moves over the northern part of the Tibetan plateau and the other one moves over the southern part. Finally, in the northeastern part of India, it develops into easterly jet streams on the southern side of the anticyclone. The high temperature over the Tibetan plateau as well as over Central Asia in general during the summer leads to the formation of the tropical easterly jet over India in summer. This easterly jet stream extends westward across India over the Arabian Sea and to the eastern Africa. The air finally descends over Mascarene High and strengthens the pressure cells. So, when we talk about low level winds, they originate from Mascarene High, move from southeast to northwest, and after crossing the equator, they start moving southwest to northeast and bring rain over most parts of India. On the other hand, when we talk about upper air circulation, the subtropical westerly move over north of India at the Tibetan Plateau. They weaken due to the presence of high pressure and move ahead in the form of easterly jet streams and power the regions of Mascarene High.